and welcome back to my channel. If you're new here, welcome. My name is Anais and I make videos related to Kubernetes and the cloud native ecosystem. Now this video is going to be about AlertManager. If you're completely new to Prometheus, monitoring in your Kubernetes cluster, observability and related topics, I highly suggest you to check out one of my previous tutorials. One of them is linked up there and the others are linked below in the description if you're curious. Now, if you want to learn more specifically about AlertManager, you are at the right content, the right video tutorial. As always, if you prefer the written version of this tutorial, it's also linked down below in the description. Link below in the description is the link to my blog post. What is AlertManager? A lot of times we set up monitoring in our Kubernetes cluster. Now with open source tools, that's likely gonna be with Prometheus. You can visualize the metrics, then through Grafana dashboards or similar, and that's the open source stack that you can set up specifically for metrics from your application. Now, Grafana provides an option for you to set up alerts through Grafana. So let's say your application reaches certain thresholds, then you're being notified about them. You can also set up alerts directly through a tool that comes with Prometheus, with the Prometheus operator called AlertManager. What is AlertManager? I've sketched this little graphic. So this is your Kubernetes cluster. Let's assume this is Kubernetes cluster. And in your Kubernetes cluster, you have, for example, a monitoring namespace. So this is, for example, the monitoring namespace. And in that monitoring namespace, you want to install Prometheus. And you can do that easily through a Helm chart that installs the Prometheus operator. Now, I'm a huge fan of the kube-prometheus-stack operator Helm chart. And that installs lots of different tools in your cluster. So it will install AlertManager in the AlertManager configuration. It will install pod monitors, probes, the Prometheus agent, Prometheus itself, PrometheusRules, scrape configs, lots and lots of other useful resources. It can also install for you Grafana inside of your cluster, the open source version. So we are using the Helm chart to install the Prometheus operator, and that runs then Prometheus in our cluster, for example, in the monitoring namespace. And we will get to the practical part in a second in this tutorial. But basically, as part of Prometheus, as when you install it, you set up the Prometheus configuration. Now, as part of the Prometheus kube-stack operator, this one, you can also install alongside AlertManager. And you would configure AlertManager the same way when you install it. You can also then add configuration after the installation. It's up to you, but basically everything that's here highlighted in blue is part of the Helm chart installation. Now, afterwards, you can set up PrometheusRules that configure the alerts that you want to be notified about. So Prometheus will basically know what to alert on and then tell the AlertManager to fire the alerts. That's the relationship between those. So PrometheusRules set the alerts, everything that you want to be notified about, and then it will forward, if one of those thresholds, one of those alerts are triggered, it will forward that to AlertManager, and AlertManager will have different configurations and know where to forward the alerts. In this tutorial, we are gonna forward alerts to our public Slack channel. Okay, so I'm connected to a 2-node Kubernetes cluster. It runs on JKE on Google Cloud Platform, Google Kubernetes Engine. As you can see, both of my nodes are ready. Now, currently I don't have anything installed. If you know my tutorials, you know that I love the tool called K9s because it allows you to do a double dot. I don't know how to call it in English. And then, for example, look at your namespaces. Or I can go into the default namespace and also look for specific, I'm already the pods. I can look for deployment, able to autocorrect, and so on and so forth. So in here, we're going to create a monitoring namespace. So also connected to the same cluster, I'm going to say kubectl create namespace monitoring. And everything that we install related to Prometheus will be in the monitoring namespace. And then we can go back and check our namespaces. Here's our monitoring namespace now created. Awesome. So we have the monitoring namespace set up. Now we want to install the kube-prometheus-stack with specific configuration, right? So I've already set up the configuration that I want to install, that I want to use. This is my monitor security example repository. I've used it in previous videos before, and I'm going to use it in this video. And here we have the different rules for the Helm charts. So we have here our prom values. If we just want to install Prometheus with Grafana and Loki, then I've used these values before. Now, in our case, we want to use all of these values, and it might look little bit complex, right? When you look at this values YAML file that we're going to provide to the Prometheus Helm chart, but it's not that complicated, I promise you. So, first of all, how do I know what to configure here? Right? If you have never worked with Helm, this is going to be overwhelming, and I highly suggest you to read the Helm book, because it has been written by the creators, the core maintainers, the creators, no, the core maintainers of Helm. And it's a really good book, and I've based lots of my Helm focused tutorials here on YouTube on that book. So you can also, if you want to have the gist of it, you can also check my Helm related tutorials. They're also linked below in the description of this video. But how do I know what I've configured here, right? That's the next thing. So we're going to go back to the Helm chart that we want to install. This is the Helm chart, the kube-prometheus-stack Helm chart. And basically every Helm chart has a values YAML file. It's very smart in that. And here are all the different values that you can configure. And usually it tells you how you can configure them and why they're configured by default in a certain way. So here are the different values. If you want to modify a value, for instance, if you want to set the default rules create to false, you would need to see what is the highest level here in the YAML, right? What is the highest level? In this case, it's the default rules. And then you need to set default rules create to false. And so you basically would copy this part and then set it to false. If you want to, for example, set AlertManager to false here, in this line, let me zoom in a bit, in this line, then you don't need to copy the create if the create is going to be true. So basically, if you want to set AlertManager to false, you need to copy default rules, you need to copy rules, because AlertManager is nested in this one, and then you can set it to false within that. That's how it works, basically. So that's how I know where I take those values from, partially. Going back to our configuration, what do these values mean? So this is for Prometheus, the configuration, and service monitor selector nil uses Helm values is by default true, but we have to set it to false. So Prometheus can pick up the different metrics from service monitors from across your cluster. That's really important. These are not as important, these are just the default, but these ones are very important, and you have to make sure they are nested. The next thing is the rule selector. The rule selector basically specifies how Prometheus knows where the Prometheus rules are, and we will get to that in more detail. But it's really important that you have a key for the selector and then a value for the key. A key in YAML is, for example, type, and then the value is Loki. So key, value. So here we're setting a key, Prometheus, and then values. Now the values in this case is an array. You could also add another name for values, and then you can use Prometheus and as a key and the value 2-3 or example rules, right? But basically this part is just needed so that Prometheus knows how to connect to Prometheus rules. And that's done through labels in your Kubernetes manifest. So we will look at that in a second. But basically, this is really important that you have that, otherwise you can't configure the alerts that Prometheus should monitor. So basically, otherwise you can't configure these alerts. The Prometheus rules, this is a CRD, this is a YAML manifest that we will install once the Helm chart has been installed. And the Prometheus rule basically specifies which alerts to track. And it has a label our labels. And then within the labels, key value. This is the key value Prometheus and then example one or whatever was set there. And this is important, this is needed so that Prometheus knows where to find this CRD, because this CRD will be somewhere in your cluster, but Prometheus doesn't automatically know how to connect to it. So it will need to have a mechanism to know how to connect to it, and that's done through the labels in your CRDs. I will show that in more detail in a second. Anyway, going back, Grafana is the same configuration. You don't need it if you're not using Grafana as part of this tutorial. You don't need it. You can use your own custom Grafana configuration, whatever you like. This is from a previous tutorial, just because a lot of times I use Loki in together with Grafana and Prometheus as well. Then the best part is the AlertManager configuration. Now, you can see here my Slack API URL, and you will have to add your own Slack API URL, because after this tutorial, I will basically make sure that this webhook doesn't work, so you can't copy it and then spam my Slack channel. I don't want you to do that. But for the sake of this tutorial, I left this URL here. So as you can see, here's the URL, the Slack API URL, and we need that so AlertManager can connect to Slack. Now, this is just some configuration I more or less copy-pasted from somewhere online. And the receiver null is kind of needed, I read somewhere, because by default, AlertManager will have a receiver null, which is here listed as part of the receivers. So we have to list it here for some reason as well. But basically, we want to add the route for receiver Slack. And the route for receiver Slack is going to be this. And we can customize the text and the message a lot more later on. But basically, it's just there so AlertManager knows which channel is allowed to post and what route to use to post on that channel. That's all this values YAML manifest specifies. If you have any questions, post them below or send me a DM or comment on this video. Probably best way. It's also further explained in the blog post, so check that out first before you ask questions. But then ask questions if you have questions. Anyway, it's something that I found while I was doing the research for this tutorial, is that it's very poorly explained where you put these information and how you configure this information, and then where you put the Prometheus alerts, because you can also specify Prometheus alerts, Prometheus rules right through the values YAML manifest right here as well. So basically in this values YAML manifest, you can also specify the Prometheus rules. However, that can get a lot more complicated, and it makes the coupling between the Helm Chart installation in your cluster, so the way that you've installed this Helm Chart in blue, a lot more tightly coupled with the Prometheus rules. And ideally, I want to manage Prometheus rules independently of the Helm Chart, because I assume that my Prometheus rules will change in configuration a lot more. They should be a lot more dynamic and have different life cycles than the Prometheus Helm Chart installation. That's why I've done it in such a way. So now we want to go ahead and we want to actually install this Helm Chart. Now you can find in the main GitHub repository, you can find a way on how to add the Prometheus community Helm Chart to your chart repository list. For this, you have to make sure that you have Helm installed. So we have Helm installed, we have kubectl installed. If you're extra cool, you have K9s installed. And then if you have everything installed and you have access to a running Kubernetes cluster, you can first add the Prometheus community charts, and then you have to update the repositories. Helm repo update, I think that's the command. And you update your entire list of Helm charts that you have access to locally. And now you can go ahead and you can install this Helm Chart for Prometheus with our custom configuration. We are going to do this through the following command. Helm upgrade -- install. So we can reuse this command, and basically once the Helm chart is already installed, it will be upgraded. If it's not installed yet, it will be installed. That is what this means. This is the release name of this Helm chart. You can name it anything else that you like. It's just important that you remember this information later on, because it will be useful when you log in, for example, your Grafana dashboard. You need the release name. But that's a different topic, and you can check out one of my different tutorials for that. Then you have here the Prometheus community chart and the kube-prometheus-stack chart from that we want to install. We install it in the monitoring namespace, and we provide the custom values YAML fast, but it's not going to be called prom values. It's going to be called prom AlertManager values YAML. And we're going to pass that in. Now, before we do that, we just make sure that everything is saved over here. And then we can go ahead and we can install this Helm chart. And fingers crossed it's going to install. But I seem to have misnamed AlertManager. Is this correct? Okay, now it seems like it's going to install it. And this is going to take a few seconds. Okay, so now it's installed, and we can look at our cluster. We can go into the monitoring namespace. And in the monitoring namespace, I will now have AlertManager, Grafana installed, the PrometheusStack operator, and metrics, node exporter because I have 2 nodes in my cluster, and then the kube-prometheus-stack Prometheus running. Now, you don't need to know the details on what the difference are between all of them. That's okay. But basically, these are the pods, and they relate to the deployments in your cluster. So these are the 3 deployments in addition to the individual pods that you have running. And then you have services. And in the services, you can port forward really nicely through pressing Shift F, I believe, when you're on K9S, and you can forward it to your local host. So we're going to do that for AlertManager, and we're going to do that through the kube-prometheus-stack Prometheus. And as you can see, prom is the release name. So whatever you named it, if you named it pom-pom, it's going to be pom-pom here instead of prom, depending on what you named it. So we're going to forward also Prometheus to our local host now, and now we can access both locally. Okay. So as you can see, this is our AlertManager at localhost 1993 #-alerts. As you can do, there's nothing here because we haven't set any alerting rules yet. And nothing, like you would only see here something, I believe, if any alerts are firing, because Prometheus is tracking the alerts. Once they are triggered, Prometheus will forward it to AlertManager. AlertManager is then managing the alerts. That's the name, AlertManager. It's not actually managing the alerting rules, just the alerts when they are triggered. Now in Prometheus, we have a section called alerts. As you can see, I don't have any inactive, pending, or firing ones. And that's something we want to change now. We want to basically set up alerts for our security metrics in our cluster. Now, to have security metrics in our cluster, we first have to have security scans that produce security metrics. And that's what we're going to use the Trivy Operator for. The Trivy Operator is using Trivy, an all-in-one cloud-native security scanner under the hood. It's a Kubernetes operator similar to the kube-prometheus-stack operator, right? An operator basically in Kubernetes automates human behavior inside of your cluster. So anything that you would do manually in your cluster, instead, an operator is going to automate that within your cluster. So the Trivy Operator is installed in your cluster, and once it's installed, it automatically produces vulnerability reports, config audit scans. So basically scanning your configurations, your Kubernetes configurations from cluster resources for misconfigurations. If anything is misconfigured, it scans whether there are any exposed secrets in your cluster, your RBAC rules, and lots more, including compliance scans. It also produces SBOMs of your running workloads. Now, the software bill of materials of your Kubernetes workloads is different to a KBOM. A KBOM is a Kubernetes bill of materials. So SBOM here relates to creating an SBOM for all of the deployments of your workloads, of your application stack. The KBOM that Trivy, the CLI, can produce, which is one of our new features, just FYI, basically scans the core Kubernetes cluster. So anything that's within your system namespace that makes your Kubernetes cluster run before I even touched anything else in this cluster, scans that for all of its libraries, dependencies, and so on. That's the kbom that Trivy separately can do, and you can check that out. The link, if you're curious, is below in the description. Also, up there now, there is the video to kbom if you're curious about kbom, but that's what sbom does. So just a friendly FYI here. But we're going to use Trivy, the Trivy Operator, install the Trivy Operator inside of our cluster. Now, if you head over to the documentation, you will find lots and lots of information. So we are on 0.17.1. And here you can find the different custom resource definitions that will be produced by this operator inside of your cluster once it's installed. But we want to install the operator first, also through the Helm chart. So again, we have to add the chart repository, the Aqua registry, chart registry, Helm chart registry to our Helm chart registry lists. We're going to do that now. Add that, and then you have to always do a Helm repo update, because otherwise you could run into installation issues if you've added a new Helm chart. If I don't use the Helm repo update and Aqua has released updates to the charts, to any of the charts within the registry, I won't have those updates. I can't install those updates. That's why you would do Helm repo update. Just FYI. Now, clear. Now we can go ahead and install the Trivy Operator Helm chart. So this is the command, but actually, since I produced this tutorial, there was a new version released. So thank you for the maintainers for that. So I hope, fingers crossed, it's going to be working the same way with the 0.19.1 version of the Helm chart. But this is basically how you install the Trivy Operator Helm chart. So again, this is the release name of the Trivy Operator. This is the chart registry, and this is the Helm chart that we want to install in our side of our cluster. We want to install in the Trivy system namespace. We want to create that namespace. We want to set Trivy ignore and fix to true, because in our vulnerability reports of the vulnerabilities that are present in the libraries that are used within our container images, here's a nice graphic right now. So in those libraries, they are scanned for vulnerabilities. And sometimes vulnerabilities are present, but they don't have yet a fix available, meaning we can't fix them. So why should we look at them necessarily? And then we want to also set the service monitor enabled to true. Why would you want to set the service monitor enabled to true? That is so Trivy is installed with a service monitor. And if there's a service monitor installed, then we told Prometheus earlier, remember, that it can track all of the service monitors across our cluster, meaning if the service monitor is in the Trivy system namespace, Prometheus will know about it, and that's how you can install the Helm chart now. Should be fairly quick. Okay, so the Trivy operator is installed in our cluster. We can check it out. If we head over to our cluster, we now have a Trivy system namespace. In the Trivy system namespace, we have lots of vulnerability reports. These are jobs, meaning they spin up and they die, and they spin up, and then once they're completed, they're dead. They're done, right? Now, once they're done, we have vulnerability reports, CRDs, in our cluster that tell us what are the vulnerabilities of the container image that have been scanned. But basically, all of these jobs relate to one deployment, one replica set of a container image that is being scanned right now. Now, if you don't manage your pods through replica sets directly, it's going to scan the individual pods. But this is what those vulnerability report jobs are there for. And then we have our Trivy Operator pod running here as well. And as you can see, this namespace is right now very active, but soon it's going to be coming down a little bit. We can check our vulnerability reports across our entire cluster. If you press 0 at K9S, in K9S, then you will automatically see the reports across all your different namespaces. So we want to set up now a rule that basically notifies us if we have within a specific application namespace new critical issues, new critical vulnerabilities, then we want to be notified of them. If there's any new critical issue, then basically AlertManager should receive that the alert is firing and should notify us that there's a new critical issue, new critical vulnerability detected in our application namespace. So, as you can see here, we don't care necessarily about the critical issue in our metric server because that's within our kube system namespace, and we usually don't have that much control over if we're using a managed Kubernetes cluster. Now, at this point, we need to tell Prometheus where these alerts are, right? So going back to our nice graphic, we haven't done this part, the orange part yet. We haven't set up the configuration for our Prometheus rules yet. So we're going to do that next. So Prometheus now when to notify us. AlertManager already knows how to notify us, but basically Prometheus should know when to notify us. Also, just FYI, this API, there's a link below in the description on how you can generate the API for your Slack channel, but you have to be an admin in that Slack channel. So you might have to create a new Slack channel. But basically, in the description of this video, there is a how-to guide on how you actually generate this webhook URL link. Anyway, so the Prometheus rules. This is what a Prometheus rule looks like. It's titled kind of Prometheus rule, as you would expect. And then it's the same API version as most of your other monitoring related resources. The metadata is again very important. Why is the metadata so important? You might ask. A good question. So this relates to what we've set up here earlier, to this rule selector section. Remember, we set up the key and then Prometheus and then the values example rule. Well, we find here Prometheus and then example rules is the key. Is it rules or rule? Rules, yes. And through this label in the metadata, Prometheus will know where the Prometheus rule is, what the Prometheus rule is, and that it can connect to it. That's the whole point of this metadata label and of this rule selector setup. Okay, so this is the Prometheus rule. Next up, we have the specification section. Specification section has a Trivy group name. Before, when I installed this didn't show up properly, which is a different issue, which I might discuss in another video. Just FYI, I'm aware of it, so you don't later point out something was misconfigured. I'm aware that there might be an issue here, but it all works, and I'm going to show you in a second it all works. Anyway, so we have the specification, we have our groups, the Trivy group name. And within the Trivy group name, we have 3 different types of alerts. The first one is if there is a pod that's unhealthy within that Trivy system namespace. Now, it's in a Trivy system namespace, and if the pod is unknown, if the health of the pod is unknown or failed. So for example, if there's a vulnerability report that has failed or nobody really knows what's going on with it, that's when this alert should fire. So here is that it has to fire for 30 seconds until we are notified. The label of it is critical. Here are the annotations. So basically different metadata relating to that alert. And then we have here our Trivy missing alert. So basically if the Trivy pod itself is missing, then this alert has to fire. Now the last thing is, which I mentioned earlier, if there's a new critical vulnerability, then we want to fire this alert. Now, it might take some experimentation to set up those alerts. There are lots and lots of useful guides online on how to set up, how to configure these expressions. That's not the issue. The main issue actually was for me to know how to set up this CRD, because there's hardly any you wouldn't believe it, but there's really hardly any tutorial that tells you once you've installed the Prometheus operator with AlertManager, set up a Prometheus rule CRD and install that separately to your cluster. People tell you this part online in lots of different tutorials, but they don't tell you that this part is within this resource. Would you believe that? Anyway, so that's why it took me some time to set that up. Maybe it's intuitive for other people. I don't know. For me, it wasn't intuitive that this section is supposed to be in a CRD within this section, within this kind Prometheus rule. So we have set up our Prometheus rule. So we can go ahead and install the Prometheus rule to the to the monitoring namespace. So the Prometheus rule is going to be installed to the monitoring namespace. Now here you can see all of our vulnerability reports, and something I really like within Kubernetes is that I see these metrics. Anyway, so let's install our Prometheus rule. So it's just a file in kubectl apply, and then file, prom rule, and then we're gonna say Trivy alerts. And that makes it easy because you can basically have a whole directory with lots of different types of alerts, and you can cluster them in CRDs and then manage them independently, right? So you can have Trivy alerts, you can have, I don't know, CPU resource usage alerts. You can have all those different CRDs, all those different files that relate to different types of alerts. Yes, you could manage it through groups as well. You can set up one YAML manifest and then manage it through groups. But what if people shouldn't have access to all of the alerts, right? I don't know. Then they can't have access to the Trivy or to that CRD. So let me just tell you what I mean by this. If you specify all of your alerts through a single CRD, right? And you just basically only categorization you do is through the group section. So you have, let's say, Trivy group, you have resource usage group, and maybe several other groups. Then whenever somebody needs to modify anything within this Prometheus rule, they will need access to the entire file, right? So maybe in some cases you want to restrict people in whether they have access to all of the different alerts or just to a specific Prometheus rule with the alerts that they are responsible for or that they should manage. Anyway, just a consideration to bear in mind. Hope that makes sense. So we're going to apply this to the monitoring namespace. Monitoring. kubectl apply file prom rule. This is the directory and this is the CRD that we specified. Now your CRD might have another name, might be another path, right? And then we want to install it. Now you could have also cloned the repository, just mentioning it. Maybe I should have mentioned it earlier. You could have, the link is in the description. I will mention that earlier. I will clip something in. Anyway, we're going to install this. We're going to apply it to our cluster. See, it has been created. And now is the moment that I always dread, because now I have to check in Prometheus if it actually has been created, that alert. So we head over to Prometheus and we refresh. And this might take a few seconds before Prometheus actually realizes that there are Prometheus rules now. So I will keep refreshing until it shows up. Okay, awesome. As you can see, the time here, if you're curious how long this took, I also didn't keep refreshing all the time. But basically all of those alerts here right now are in green because they're inactive. They're healthy. They're not been triggered. Basically, there is no unhealthy pod in the Trivy system namespace. The Trivy Operator is not missing, and there are no new critical vulnerabilities. So let's change it, right? This is the exciting part. We're going to create a new namespace called test, because this is the alert that's related to the test namespace. And in that namespace, create namespace test. We're gonna set up a nested deployment. Basically, I have here a deployment, an app manifest with a deployment with an outdated React example application that has critical vulnerabilities, lots of critical vulnerabilities. I'm sure there's lots more wrong with this application, but that is wrong with that application. So it's the app manifest that we want to install. So kubectl apply app manifest in the test namespace. Oh, that's great. Yes. Okay. So going back to the namespaces, we have our test namespace and we have the Trivy system namespace. In the Trivy system namespace, here's just a vulnerability report for our new deployment for the nasty React example application. So this is just running, scanning that container image for vulnerabilities. Really exciting. We can see it live, live reporting. So here's our example application or container that we've installed inside of our Kubernetes cluster. And in here, it just completed the vulnerability scan. So we can head over to our other namespace, to our test namespace. Here we will see two parts because this part is our replica set, and that replica set is defined in the deployment. And here's our deployment with the two replica set. Both of them are running, and we've just completed our vulnerability report. Our vulnerability report is here, and it has 8 critical vulnerabilities in here. It's a lot. And then 58 high ones, 37 medium, 2 low. Nice. Okay. So now we should see in a few seconds Prometheus, this alert go red because there are new critical vulnerabilities that are more than 0 critical vulnerabilities detected in our test namespace, basically our application namespace. So you would want to have probably for each application component, maybe each namespace, you would want to have separate alerts so you can manage them easier. Because if I would just say critical across the cluster, I mean, that's one matrix, but maybe I care more about some critical ones in some namespaces versus critical vulnerabilities in other namespaces. So let's refresh and see. It's firing. Okay, so now that this critical alert is firing, it should also appear in AlertManager. So refresh AlertManager, and here we can see our firing alert. So it's of type CRD, the Trivy new critical vulnerability. Trivy found a new critical vulnerability in a deployed container image. Obviously, when you use this in production, you would make it more detailed. Here are the different labels that we've added. To this alert, you can modify the labels. Now we can go ahead and we can add links as well to this alert. We can also go ahead and silence it. We can also set the, basically to this alert, we could also set links to specific Grafana dashboards and much, much more. But basically now that this is firing, this alert, we should have also received a notification on our Slack channel, because that's the point, that you want to ultimately forward these alerts once they are firing to your specific destinations, to those receivers as they are called by AlertManager. And as we can see here, oops, I was so excited. And as you can see here, okay, this is just my personal Slack channel, so please, nobody join this one. And as you can see here, AlertManager is firing. Here are all of my previous ones when I tested this, when I set this up. As you can see, there's a lot of effort going into this tutorial, so you better like it, okay? So anyway, now that we've got that over, the like and share this tutorial, we can go back to the interesting stuff. Thank you. AlertManager is firing. We have the alert here. We can then set here the link to, I haven't done that yet, to Grafana, and also a link to Runbook to tell, for example, more junior people or people who have never really, maybe never interact with critical vulnerabilities and don't know how to fix them, don't know what to do about them, but receive the alert, that they know through those Runbooks what actually to do about them. That's the whole point of this, right? That you basically provide information and quick links. Now, once an alert is firing, you would also maybe set up, for example, a connection to PagerDuty. So if that's something critical going on, you actually notify people when they're sleeping as well. Anyway, so we could go ahead and we could silence the alert. We could also fix the alert, for example, by just deleting the deployment. That should fix it. We could obviously also fix the critical vulnerabilities, but this is just for demonstration purposes, so I'm not going to go to great lengths to fix a shitty application. Thank you. And I'm allowed to swear on this channel. Anyway, so delete. We're going to delete this application, and with it deletes automatically the vulnerability reports, because the vulnerability reports are connected by Trivy to the replica set, to the deployment. So the Trivy Operator uses the Kubernetes garbage collector to clean up any resources that are no longer needed. Otherwise, you would spin up applications, you would have vulnerability reports, you would delete applications, and the vulnerability reports and other CRDs from the security scans would just lie around in your cluster, clutter your cluster. And we don't want that to happen, because clutter is costly, very costly. So now that we've deleted it, our alert went back to green. Yay! Anyway, this was that situation. Now what happens if somebody is like, oh, I want to install something very nasty in your cluster, but I don't want you to be notified about it. I'm just going to go ahead and delete the pod that's supposed to run the scans. In this case, the Trivy Operator pod. So we're going to go back to our cluster. We're going to go to the Trivy system namespace and we're going to just delete this pod because this is the kind of alert I came up with on short notice. So we have to trigger it. Oh, that was stupid. We need to delete the deployment, not just the pod. I hope I'm entertaining you. So we delete the deployment because then the operator cannot spin up the pod again. So if the deployment doesn't exist, we would have to reinstall the Helm Chart resources for the deployment in the pod to be back. So there are no pods now in this namespace. If we go to pod, no, not pod budget, pod. Oh. Maybe even both alerts should be firing now. Let's see. No. Let's wait 30 seconds just to be sure. So now we have one alert firing saying that there's an unhealthy pod, which is a vulnerability report that caused an error. Now, the Trivy Operator, here's an expression missing. No, actually, the container Trivy Operator is not present. This should be firing as well now. So I'm going to check that, but this should be firing as well. But as you can see, this is correctly firing because there's an error pod in the namespace. And this is it for this tutorial. I hope you enjoyed it. As always, the link to the written tutorial, the link to the blog post is below in the description of this video. If you enjoyed this tutorial, it would mean a lot to myself if you could give it a thumbs up and subscribe to my channel for upcoming videos. These videos take a long time to produce, both written version as well as the video tutorial. And they are for free just on my YouTube channel, so it would be really, really great to have your support. Also, I have a more or less weekly DevOps newsletter, so if you're curious about the things that I enjoy reading and writing about on a weekly basis, then subscribe to my DevOps newsletter. The link is also below in the description. I really hope to see you in one of my next videos. Have an amazing day. Bye bye.